Hi, sixth graders. I wanted to talk to you today about a method when studying probability that can help you figure out a probability where the exact calculation may not be clear. This is referred to as the Monte Carlo method. This is a method where you're taking kind of a best guess at a situation and just simulating it several times and seeing what your answer comes up to be, well, somewhat close to. If you're doing such a random simulation, again, we call this the Monte Carlo method. So this example, and I'm going to have you simulate this yourselves with a Google Sheet using the rand between function. The setup of the problem is this. If you have, let's say you have 10 ducks right here, and you have 10 hunters that are perfect shots. They all take aim at one duck, and they shoot, they don't miss. The catch is they don't know who's shooting at which duck. You know, they're selecting 10 hunters, they're selecting 10 ducks to take a shot at. The question is, what's the survival rate for the ducks? How often, you know, if you're one of these hapless ducks out here, what's the probability that you survive? Is it 1 out of 10? Is it 0? Well, you can simulate it and find out. So what we can do now, again, you know, this text, as you see right here, it says, hey, we can take some random block. I don't want you to take a random block of digits. We're going to, as I said, take a Google Sheets form, so start up a new form. And what I would like you to do is you are going to create a nice little project here simulating the duck hunting problem here. And in this case, what we're going to do, these are just numbers up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're bolded, they're underlined. And then we create random numbers. See, so like this little cell right here is highlighted up here. It says equals rand between 0 through 9. Well, that's all of these. What you'll want to do, of course, is you'll want to create that equals rand between 0 through 9 and enter that on 10 consecutive rows like this, and then highlight as many rows down as you want to go, tap in the middle of that and select autofill. Work with a classmate to try to help figure this out. Now, once you've got that, you will count the surviving ducks, and here's the formula for it. You catching this? I put equals, and you put in 10, and that's a subtraction sign right here. 10 minus count unique. And what this is doing right here for A6 through J6, that happens to be the row I have highlighted. Obviously, you'd start, if you were starting up here, if you're on row L3, you'd say equals 10 minus count unique, A3 through J3. Hope you understand that, the way spreadsheets work. And again, you will copy this down and drag it down. But hopefully, does that make sense when I said count unique? So when it's counting A6 to J6, as you see, there's a couple of doubles on here. There's 4s, there's 6s, and there's 1s like that. And so you have, that's just 3 different digits, 4, 5, 6, 7. And so that's 7 different numbers that are happening on here. If you scroll down, you can see some other examples here. It says surviving ducks. This one had only 2 surviving ducks because 3 hunters shot at 2, but then 1, 2, 3, 4, 5, 6, 7, and then the 2s make 8. So only 2 ducks survived that shot. Okay, but again, I'd like you to make this spreadsheet yourself. So then this final cell over here, I have average number of surviving ducks, and this, as you can see, equals average, and then I average L2. Well, I should have said L2. L2 doesn't have a number, so I should really start this with L3. It kind of ignores the surviving ducks, but instead it averages all these numbers right down here. Understand? Now, one other thing I want you to. One thing I do want to be clear about this using the duck hunting problem for Monte Carlo method. I'm being a tad disingenuous because this one, the math is provable because each duck, as you can see, has a 9/10 probability, 90% chance that a hunter is not shooting at them. For that to carry over through all 10 hunters, of course, we will actually take 0.9 to the power of 10. That will be the individual probability that that one specific duck does not get hit. I multiplied that probability times the 10 ducks, and that tells me my average, oops, sorry, not that, I'm sorry, I run along the wrong thing. That's my expected average of surviving ducks. And as you can see on my spreadsheet, I got pretty close here. You had 3.481 versus 3.486. I would never expect it to hit it exactly, of course, but I went all the way down to 2,000 lines, worth. I dragged a long, long way. So yeah, my expected average over, the more trials I run it through, if each one of these lines is a trial, the more likely I am to get an average that's really, really close to 3.486. That's, again, this is my expected average, and this is the precise calculation of that average given 10 ducks. I hope that makes sense. I want you to work on that today. Create a Google Sheet and just, you can just title it Probability Project. This is the first of a couple of things I'm going to ask you to do. Hopefully, when I return, you will have this completed and ready to share. Don't share it with me just yet because you're not quite done with it. But at the very least, you will have completed the duck hunting problem on a Google Sheet for me for today. All right. I hope you're having a great day. Be sure to subscribe to my YouTube channel. Smash that like button, and be sure to purchase from all the various merchandise options at the bottom of the page. Okay, just kidding. There's no merchandise options. But yes, you can hit the like button and subscribe, though. You can at least do those two things. Have a good day, and I'll talk to you again soon. Bye now.